What I always try to do, though, is I try to take fairly complicated things and narrow them down to a very practical purpose, scientific-y thing sometimes, and that's exactly what I'm doing here. I actually am trying to solve a problem. So I was on like Reddit or I don't know, some site, and I saw this diagram right about the time when I was thinking about natural language toolkits, and I saw this diagram, and this diagram's evil. Okay, and it's totally wrong, and I've been told by many people why it's wrong, and I'll tell you why it's wrong shortly. But it's very interesting. It was very interesting to me. I was like, that's one of those things I saw real quick, and I wanted to share it with the whole world. Like, hey, look what I found. I'm so brilliant. But evidently, there's a lot of problems with it, and I'll get into those. But generally, it's still kind of interesting. So the idea here is basically that languages, these are European languages, that these languages are grouped in certain ways, where they're related to each other. So you have Germanic languages. English is a Germanic language, and the article actually goes into great detail why English is a Germanic language. I'm not going to go into that great detail. But anyway, so and then you have these Slavic languages that are in a group here. And I'm like, well, what is this lexical difference, okay? What is that all about, you know? Bring it down to layman's terms. And what I found is in researching, first off, it was the site of the site says the guy is Russian who data was based off, and he's actually Ukrainian. But I found that out so late I didn't add it to my presentation, but I can find you the original sources of the Ukrainian research that did it. And it's totally based off of vocabulary. And I found that very disappointing. And the reason why is because, as we all know, language isn't just vocabulary. Language also has to do with composition of sentences and all that good stuff, right? So that whole graph was based off of the idea that there was a movement between the word bread to brought, bread to pan, bread to child. I don't know how to say it. In Polish here? How do you say it? How do you say it in Polish? Chleb? Chleb? Yeah, chleb. I said it right. Whatever. And then what I also found funny is like I looked up, mom. And so in German it's mama. I know this is going to be terribly surprising to you. And then in Spanish it's mama. In Polish, come on, join me here. All right. So obviously movement and things like that. Those are of a language through a word. It doesn't do it for me. There seems like there's something wrong with it. Generally, the glottochronology, how you say that, is chronology. Exactly. And it's a pretty cool diagram of how it's spread out from area to area in these languages. And that makes a lot of sense from a timeline perspective. And that's totally historical linguistics, right? But, now we have all these computers, so we should be able to do something more with this. I go back to these word lists and lexical similarities. And, if something is 85% similar, according to lexicons, then it is a dialect. So anything over 85% more similar is dialect. So, I was born in Hammond, so I probably speak some dialect. I don't even know what it is. But, again, the problem with this, and when I got into trying to do this with actual computer science and trying to actually compute this, I ran into this point number 2, and that's the one with the footnote here. A trained and expert linguist, it's really in small type here because I was going to not tell you that exists until later. Because I was going to do all of my computing based off this concept. I really ran into a dead end because what actually has to happen is a linguist has to go in there and has to make a decision based on an expert. Has to go in there, and I'm not talking about a computer expert, I'm talking about a guy who's an expert or a woman who's an expert in language. And has to make those decisions, determinations of words and how they go from one language to another. Rolls back up into saying these are the lexical differences. Which is great if you have an expert telling you what these words are. So, language, British English, The Clash. Everyone listen to The Clash? London Calling. London Calling's a great album, by the way. I don't want to get off basis or anything, but The Clash are a well-known band. The Clash is a well-known band. Have you the time? Do you have the time? Obviously, they're the same language, and there's some differences between them. And these are computable differences, by the way, too, when you look at a sentence. But if you look at the word, band, they're the same. and you look at the word time, they're the same. So this is going back to the idea that these differences in words aren't as interesting. So then we come into this problem that, language is actually kind of a complicated thing. It's cultural, it's complicated. Hey, but so one of my problems was thinking that, okay, so I have a great engine behind this that I'm going to show you shortly of taking language and parsing it and doing things with it, adding grammaticals to it, adding logic to it. Really cool engine, by the way. This library just blew me away when I started getting into the details of it, and there's a lot to learn from it. But as far as from a data perspective, from the input side, I was like, what do I have here? I have some Shakespeare text, that they parsed and added tags to. I have some other text they added text to and stuff like that, and it's kind of outdated. And what I found is this Transiflex. Everyone heard of it? I mean, it was pretty amazing. It's basically a translation crowdsourced tool. So an open source project or something like that, or even a closed source project can use their tool. They're a software company. And it's hard to see here, but basically it shows you suggestions of translations, and these are very GUI elements that you'd find online. Interactive charts, hidden, the word hidden. You can adjust your level of detail, dimensions, and colors of the chart by tweaking the blah, 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 tweaking the code below. And then, so they do this crowdsourcing translation in German and 30 different languages, 40, 50, 100 different languages. So it's really quite an impressive online tool, but a lot of people build with their SDK. So why am I telling you this? Well, when I started getting into my example, I grabbed this data because it's a real world example of how language flowed now into these different languages, to modern German, modern contextual text. And when you talk about a dialogue that you're showing someone online or through an application, a dialogue, is coming closer to the spoken language than our literature is, because it is speaking to us on an interactive level, like we would talk to someone when we're walking down the street. So the translations are quite interesting, and there's a lot of data there, and it's also publicly available, and I can grab it and run a whole bunch of stuff in the cloud. Yay. Enter the snake. So you said, this is a Python talk? Yes, it is. Where's the Python talk? Well, it's starting right now. So you have these lexical statistics, and I was looking at the data sets for it, and there's a WordNet only data set in English, but there's something that can be done with that. There's something called lexical density, and this is going to be the focus point of the rest of the presentation. And there's also this analytical structure. This is the follow-up presentation that I'm giving in 6 months, because this is about as far as I got, and it's pretty far. So you'll see in a second. And the whole thing about lexical density that occurred to me, and this is just from practical real-life experiences, doing internationalization. Anyone here ever taken English and translated it for your client or for yourself to German or anything like that? There's several of you. And have you ever noticed how the German is really long? I know that sounds really stupid, but it really is. It's really long. And UI constraints. Doesn't fit, man. Hey, designer, you suck. I don't mean that, everyone's saying. But there's also a lot more words, and there's a different construction of the words and sentences that go from these languages. So I'm thinking that, so if I could identify these nouns, adjectives, and verbs, and I can identify these things that aren't nouns, adjectives, verbs, I could probably calculate the density of a sentence. So that's where we enter here. And what happens with NLTK, and here's where I'm going to jump into my IPython notebook real quick, is it does have the ability to identify some of these things. I have to find the right window. And anyone who's used an IPython notebook, I'm pretty impressed with it. Basically, just a real quick 30-second thing about it is it's basically like IPython but through a web interface, and it has a backing of a kernel and things to execute this code live. So you basically have these sections of things, and you can say this is code or this is markdown or header or whatever. And usually, if anybody here uses IPython itself, this looks just like it, right? And it actually, oddly enough, it actually also does tab completion when I was doing this in the browser. And I was like, where have I been? Kansas, actually. But no, really. And so, you can kind of execute this code as you go along. And the first step, and like this, when you get into this, there's a book that's associated with this framework. It's really tightly coupled with it as well. Because what happens is the sales of the books feeds the development of this, and there are 4 developers on it or something like that, and they feed into each other. And the examples are amazing. It's a very comprehensive thing. One of the first steps when you go through the tutorials in the book is you download grammatics, and you download different text sets for training that are already tagged. And that's kind of the basis of it, is that there's a step where you take this data and you train it, and it becomes the software becomes aware of that, and that's what you use to do further analysis. And in the book, they will tell you to take a test set, and I think that's what I do in my examples as well. So as that's coming up, and it should be, this one's executing right now, and this is the interface to do the download. Let me go back to my slides. And bear with me here, because some of these things do take a while to execute, especially when you're training. But an overview of density here is, this is just a screenshot of what I had before. But basically, there's shortcut utilities to NLTK. So I take this text string, the quick brown fox jumps over the lazy dog. And the idea of that goes back to saying that that's a lexically dense sentence. And I got this from a grammatics website when they were explaining grammatically dense. If I were you, I wouldn't do that with these. I don't know what they're talking about, but that's not a dense. It's a very not dense sentence. The reason that's not dense is the denseness. That's a good question. The denseness is based off of the number of nouns, adjectives, and some verbs and adverbs. So when you parse this, you get a parse tree here. These are tokens that are associated with each word in the sentence. Here they are, and here's the tokens. And I put a little key here. So a DT is a determiner. What we really care about here is these nouns. Look how many nouns there are in this sentence. And when you look at this one, there's a lot of personal pronouns like I and stuff like that. So the denser one is the one with a lot of nouns and verbs. The one that's less dense is the one with a lot of adverbs and verb past tense and things like that. So has my IPython shell come up yet? So in theory, that should come up at any minute, or I could kill it. But here's that same as example. So what we're going towards here, though, is we're going towards, I want to check the density of sentences that are translated, but I want to do them in 3 different languages. And the languages I chose, and I'll go back to my original slide so that you get an idea where this is going. I chose English, and that's my base language. And actually, that's common over the world to have English as a base language. Aren't we lucky? And then the other 2, I wanted to be in a different group. So the English is in the Germanic, and then there's Portuguese here, and there's Spanish that are in the Romance languages. And so I did the comparison of English, Portuguese, and Spanish. So if my comparison is correct, and it's not based off of the same thing they used to make this horrible diagram, and the reason this is horrible, by the way, is there should be weights associated with all of these, of course, and then and there's some miscalculations here. So, but anyway, these 2 should be closer to each other, obviously, than English when I look at the density. That that's just one factor, and it's not real scientific, but I'm just trying to bring another dimension. And remember, my goal is to learn the toolkit here, not to really discover where English came from. Let me go back to my... Yeah, I'm telling you how awesome this is, and it probably hasn't executed yet. Maybe it has, and I just don't see it. Let me close some stuff. So what should happen is the downloader should open up. And the downloader has a lot of data sets that actually has to pull in from different sources, and it's a little TK app. But I'm going to... Yeah, I think I should kill that kernel.
You're running, you might not have to restart it. Just run that cell again. I think the Windows version is a little buggy.
Okay, let me run it again. Interrupting kernel. I'll tell you what. I'm going to do it the old-fashioned way. Brute force. Okay. So kernel's busy now. That's good. So it actually is doing something. So what was interesting about this is what we're failing to have is there's only a certain number of data sets available to this. And the other complexity of it, and I was going to show you this other code here, which I will while this is running, is that the tagging is different between data sets. So my tagging to say that this one data set is a noun is different for the English data set than it is for my Portuguese and for my Spanish, because I had to get them from different sources. And each source, for probably academic reasons, who knows why, decides to use a little bit different tagging. And there's also tagging that exists in some languages that doesn't exist in others, because of the way that the language moves. But generally, that's why I'm only looking for nouns and verbs and adjectives here. Because those are the three things that kind of do transparently go through at least these Romantic and Germanic languages. If I go on to other languages, they may not, but those do seem to have that. So basically, I'm figuring out my density based off of those things, not everything else, because there's a lot of everything else. There's 40-some tags for English, and there's some languages that have up to 200 tags of identifiers. So, yeah, so I'm getting more and more complicated here, but as we get closer to our goal. Does anybody speak 2 languages here? Anyone? Oh, wow, a lot. What languages?
I speak 3, actually.
3?
Romanian, English, Arabic, French. Well, that's 4. I don't speak French.
We don't speak English, though. Interesting. So, like when you're composing sentences in French versus English, do you notice a length difference or a complexity difference between them? Absolutely. Okay. So I'm still trying to determine why didn't we use density as one of the metrics for this, for measuring differences between languages, but and I'm going to get to another dimension too, and that's the structure of the language itself. When we start making structure trees of the language, saying I'm going to move this part of the language over to this part. Okay, so my little IPython shells come here. So there's corporas, which are basically tag texts of different sorts, and there's quite a few in here. And this is a little GUI that came a part of the framework. And I'm quite impressed with how organized they are. And I just downloaded them all because I don't care about bandwidth. I was using our fast network. I was on Google Fiber, and so. They're interesting. So we're using this ESP, the CES ESP tree bank. And a tree bank is basically just saying, here's associated tags in context. And what I mean by context, that's another thing. So that basically, I will tag a word in a sentence, but for instance, let's say it's just Spanish, for example. It has a DE, the word DE in front of that word. That would change the tagging on it. Other rules like that exist in there too, because they're contextual. So that's cool. So that executed, and I got to kill it now. Let's go on. So everyone following this? It's pretty. I'm trying to make this very practical. So hopefully I'm achieving my goal. If not, holler at me later. but this is just the little program inside the program that I'm using to figure out the complexity. And I'm basically just dividing those words that are nouns and verbs and adjectives, So, and that's all that does. And then to test this, that those two sentences we used before, I should be executing this code. I shouldn't be just talking about it. It's kind of cool. You can change stuff as you go along. So these are actually executing right now.
It thinks that quick is a noun.
Yeah.
Blame the data set.
It's wrong. It's wrong. And there's a percentage of error here. So when we get to this other part here, we'll talk about that. So the problem was, so those are all built-in functions, and obviously they're wrong. There is a margin of error with it, but there is no built-in function for Spanish. So we had to do that ourselves. So the steps to basically training this data, the right way to do it, according to the book, is you take a subset of the data. You take the sentences, you take a subset of data, you take 10% for testing and 90% for training, and you train it with one of these taggers, and there's 6 or so, I don't know the exact number available to it. I used this one. It took a little longer to execute because it had a higher accuracy rating. So it had the 84.9%. The other ones were a little bit lower. So I chose that tagger, and I figured the accuracy by just taking that test data and running it, evaluating it against it. And then I do the tagging. So when you see these tags, that's what I was meaning. They look a little different. So you have to interpret how these tags translate into the tagging system for the language. And there's documentation. I'll share my slides, but there's documentation on which tagger, which tagging library defines in which. And luckily, the documentation is written in English. Oops, I'm way at the top. Okay, so I'm going to continue going through this demo. So we tag a couple sentences here. Gato, which means cat, is obviously a noun, so it does that one right. The verb is a verb. I would have to look. Let me see if I still have that document open. Yeah, it's. I don't know, but I'll figure out. I don't know. I was more concerned with the ones that I care about because there is a lot of identifiers I didn't understand. And then with Portuguese, then I did the same thing in Portuguese. So there was a corpus for Portuguese, so that's what they call them, is corpus for Portuguese, and you do it exactly the same. You just train on the Portuguese. So what's interesting about the framework is you can train on anything as long as it's tagged. So all it does is it figures that out, and then it has 85% accuracy as well. And then I took the strings from Transiflex, and I said, here's the English string, here's the Portuguese, and the Spanish. There's a couple Spanish ones, we use them both. And then just really quickly, we go through each string. We find the density of the English. We find the mean of the densities of the Spanish and the mean of the densities of the Portuguese. And we print them out, and we check the distances. So the distances, basically I have 0.15 between the English and the that would be the Spanish, and I have 0.21 between the English and the Portuguese. And then as we expected, the Spanish and the Portuguese are much closer to each other, which is only 0.06. So according to that little simple example, it does support the diagram that we saw. So not real scientific. Yeah, I know, right?
So Spanish and Portuguese are less dense?
Yeah, they're less dense. Yeah, there's a lot more identifiers in there. Yeah.
And they're less efficient as
Yes,
culture.
yes, but more romantic, Yes, exactly. And then I dove into a couple other things. So what I really kind of was wanting to do here at some point, this might be, like I said, 6 months from now, but is the other problem with language is it's abstract, right? And I don't know if this will play. I don't know if we can hear it. Oh, I can't. Is there audio here? I can't hook this in. Can I? Oh yeah, I could do that. I could do that. I got to turn on the speakers first. We're detecting problems. My God, does anybody know how to use Windows here?
Yes. Give it to me and I will wipe it.
Who wants to load Linux on my laptop tonight? All right, here we go. Test, test. This isn't on either, obviously. Test, test. Is it loading? Oh, Groucho. Right, right. All right.
There you go, now you can do that.
It's really not worth it. Really. Okay, so he basically gets up there and says, I shot an elephant in my pajamas. I don't know how he got in there. So the whole point of the skit is that the language, I have two mics on now, that the sentence is poorly structured, but the framework has to kind of understand that there's two possible structures for this, and it actually has the ability to do this. So it has the ability to say, you can see how these structures work. These are larger subsections of these, and you can say, I shot an elephant in my pajamas, or I shot an elephant in my pajamas, right? So
this is like the panda eats shoots and leaves.
yeah, he shoots and leaves. Yeah, it's kind of a grammatical play on words. And he says, I wish it would come up, but he actually talks about some other things.
Refreshing the whole thing.
Refresh the page. Wait, where's our actors?
One morning, I shot an elephant in my pajamas. How he got in my pajamas, I don't know. Then we try to remove the tusks. The tusks. That's not so easy to say, tusks. You try that sometime. Tusks.
Oh, simple tusks.
Pardon me, my name is Spaulding. I've always wanted to meet you, Mr. Chandler. As I say, we try to remove the tusks. But they were embedded in so firmly that we couldn't budge them. Of course, in Alabama, the Tuscaloosa. But that's entirely irrelevant to what I was talking about.
Irrelevant. Irrelevant. Okay. So, we like to have fun here. All right, so from the example perspectives here too, there's there's some good examples of saying, module has no attribute book. I'm going to import something here. So here's a dispersion plot right out of the book example. So easy to generate. Comes right up. And it shows the frequency of these words in this data set. And this data set is book text 4, which is inaugural address corpus. So you can see throughout these addresses how we talk about America a lot towards the end of the talk. America. Okay. So, but it is interesting. And these tools are very, very developed. I'm impressed with them. A quick tabulation here. And I'm just kind of going in, giving you a little extra here so that you can see what it does. But it takes a while to execute sometimes, and I have to run my tabulate first, then run this. So when you're running these, when that star is there, that means it's actually execute kernel busy. And there's my tabulation of these words. And these kind of interesting. So these are the news sources and brown categories, and so in news, you see how the word will is really dominant, and in hobbies it is as well, and in romance could. It's kind of funny. So these are just showing some of the tool sets they built in here too, and comparisons of words. I'll just let these execute. And then when you start getting to the more advanced examples, you actually can build grammars. You can build grammars, and you can also build logic notations here for determining certain things. And this is the one out of the book, and then I modified the one out of the book below. But basically, this notation here, boy sees Cecil, so boy to be, and so on and so forth. The C's, B's included in a Cecil C, so there's a CB connection here, so that's equivalates as true. And it also equivalates to, it knows the difference between the all versus, so if I execute this one here, of course the same results appear. And then I just modified this as Cecil sees a boy instead of Cecil sees every boy. And I look at that, and that also equivalates to true, but you notice the operator here changed to an and. So that's pretty cool, because you can go pretty far with that. If you're trying to actually take in input of text and generate some logic based on that, it's pretty powerful stuff. You start getting into that sort of thing. So, any questions on anything? Any questions on this framework or what I was trying to do with it? So, a little bit before I take a question. I think ideally where I'd like to go with this is saying that these graphs that they can be generated based on these different languages, if there is some way of normalizing them to a level of satisfaction without an enormous margin of error. These comparisons can be done based off of differences in how the sentences were restructured on languages versus a vocabulary word. I think the vocabulary word methodology is kind of like, well, yeah, maybe, but what if you switch a whole sentence around? Does that matter? I think it does. I think density matters. I think there's a lot of variables here that just aren't being considered when you're seeing how these languages moved. Hit me.
A couple of years ago, there was an article about somebody who published an article in a math journal that was completely nonsensical.
I couldn't imagine that happening.
Generated using a whole bunch of crap, right? And the fun thing was that figure out that it's just really worthless. It might be interesting to run that paper through your
the nonsensical paper, see if there's logic that exists in it. Okay, so yeah, your recommendation was, so it wasn't a question, it was my recommendation is to run a nonsensical mathematical paper, correct, through some analysis. Yeah.
So have you considered looking at the Shannon information in different sentences, in the same sentence but in different languages, to see if Shannon information is either invariant or if you can tell by Shannon information?
Okay, the question is whether I've considered using Shannon information to compare the sentence fragments.
As opposed to density.
Opposed to density. No. Because I haven't parsed my sentences yet.
You don't have to. You can just do it based on each word.
Oh, on the word basis on Shannon. No, well, yeah. So I looked at that, but I wasn't able to get good results. Yeah, I looked at it a little bit. I think that I really want to parse the segments to get the to get that.
What's Shannon?
Yeah, what's Shannon?
Well, so in this case, I'm thinking of the Shannon information or the Shannon entropy. So that you take for each word in the sentence, you take its the sum of the word and the word's frequency times its log frequency, and then you take and then you take the inverse sign of that sum, the summation, and that would be the Shannon information for each sentence.
For each word, though, right?
Yeah. And so this would be, this would be an alternate metric to.
I think it's great.
That's really interesting. What do you?
So did everybody hear what he said, though? Basically.
Could you be a little bit clearer about what you mean when you say the weight of the word?
the frequency. So
Yeah,
you
frequency,
take
exactly.
you take like say take Wikipedia as your corpus. You take every single you take the frequency of that word occurred in any sentence ever in Wikipedia, and then like that's the frequency of that word.
So it requires a corpus.
It requires a big corpus.
So yeah. So so to expound upon that a little bit, when we were looking at one of these examples here about related words, my thought on that was, so when I say similar word here, woman, I could use a Shannon information to figure out which of those related words is the word I really care about because of its higher value level in that corpus. Then use that as my basis word instead of the word that was actually there. And the other thing that the library does nice is it finds base words. So like it finds base words, but I still keep running into this problem that it's all really good on the English level, and it's kind of bad on these other languages. Like there just isn't as much data. Like you saw already, there's some misassociations with it. So I kind of think like I almost want to encourage people to be aware of this project and work on it or something because the data needs to be better on the other languages. Oh, there's so many hands. In the back? No, you're back. Yeah.
Did you look at or consider any artificial languages or constructed languages?
So the book has artificial languages in it. No, because I was really focused on more on those. It took all my brain power, believe it or not, because I was using all my pea brain to just process those 3 languages. Okay, but yeah, I mean, it's interesting though. You know, what is that Trekkie language? I don't know. Klingon, Esperanto.
Esperanto and Klingon were the 2 illustrations, but more people speak Klingon than Esperanto.
More people speak. I'm in the right place. Paul.
So the examples you gave were mostly of like parsing data and data statistics. Does the library do inferences and predictions?
Does the library do differences? Inferences?
Predictions on say read the data and based on pattern, we'll say, oh, this is German, this is Spanish, based on what.
Does it figure out what the language? I wonder if you could use. I don't. Not in the book, but I bet you we could figure that out.
Because like the library, like, doing like base and Markov, they're Python library.
Python libraries to figure out what language it is to start with, right? Well, you know, when I go to like Google Translate or something like that, and I type in and it says just detect which one I'm using, yeah, but it has detected wrong. I put Tagalog in there by my friend. I put Tagalog. Jason.
What about Asian languages? Chinese, Japanese, Korean?
Asian languages with this? Yeah, there's some Asian language support in the corpus. There are Asian language support in these corpus. So if I just, here, I'm going to do live code here. I always do. So bear with me. This is a live demonstration. You guys are going to, this is going to blow your mind. So, oh, did you see that? I typed something in and it, woo! All right. Someone buy me a beer. All right, so if you look through here, this is not annotated, unfortunately. There's Indian in here, yeah. I don't know if is Indian considered an Asian language? I don't know. Let's go back to. Here we go. We're going to get into the theoretical conversation here. Okay, last question.
Okay, thanks for your talk. It was enjoyable. One of the areas that I'm trying to explore to solve the problem is text-to-speech.
Text-to-speech.
So, is there anything in this library related to that?
Yes, yes. So there's a chapter in the book with this library. If I can find it. A lot of windows here.
The problem that you can maybe help is with quickly, like if you have a highly inflected language, like Latin,
Okay.
or Greek, right? Like the word bonus comes from Latin, but the U.S. at the end, it tells you that it's nominative in the case,
Yeah,
it's
yeah.
plural, its gender is masculine. If you were to vocalize that, the computer should be able to basically take that text and pronounce it properly based on the grammar. Does that make sense?
It does. Here you can see all my search history here. So there's a book. So if you just go to this website here, nltk.org/book. When you start getting into, I think it was, yeah. So you start getting into some of these sections here, you're going to be quite amazed. But it does talk about specifically generating, text to speech with it. Yeah, I'm pretty impressed with it in natural language processing with Python. So it's a pretty worthwhile library. And I think it stands up against any other language libraries for that purpose. So I venture to say. Okay, that was the last question. Thank you very much. We'll take a 5-minute break and get set.